Good day everyone! Welcome to my YouTube channel. Today, I will be discussing the most essential learning competencies in Mathematics 5, Week 1, Quarter 1. What will you learn from this lesson? Uses divisibility rules for 2, 5, and 10 to find the common factors of numbers, and uses divisibility rules for 3, 6, and 9 to find common factors. But before we proceed to our lesson, let us analyze first the given scenario. Rachel is very worried about her exam tomorrow. She asks her mother for help. Let's watch and listen to Rachel's conversation with her mother. Mommy, can you help me with the prime factorization problems? I have a test tomorrow at school. I am worried about my exam, and I'm feeling nervous. Rachel, just focus on your studies and you won't face any problem. Don't worry, I will help you. Did you test the numbers first? Test the numbers? What test is that, Mommy? I'm talking about test of divisibility. Do you know that we can tell if a number will have a remainder when it is divided even without computing or without actually doing long division? To do this, we have to remember the different divisibility rules. Let's check out the divisibility rules from number 2 to 10. Okay, Mommy, let's begin. Let's define the word divisibility. Divisibility is the capacity of a dividend to be exactly divided by a given number. When is a number divisible by another number? We can say that a number is divisible by another number if there is no remainder. Let's begin to study the divisibility rules for 2, 5, and 10. Divisibility rule for 2, which states that if the digit in the ones place or the last digit of a number is 0, 2, 4, 6, or 8, it is divisible by 2. All even numbers are divisible by 2. Let's have an example. 70. The ones place or last digit of 70 is 0, which is an even number, so 70 is divisible by 2. 152. The ones place or last digit of 152 is 2, which is an even number, so 152 is divisible by 2. 834. The ones place or last digit of 834 is 4, which is an even number, so 834 is divisible by 2. 2196. The ones place or last digit of 2196 is 6, which is an even number, so 2196 is divisible by 2. 36,758. The ones place or last digit of 36,758 is 8, which is an even number, so 36,758 is divisible by 2. All even numbers or a number that ends in 0, 2, 4, 6, or 8 are divisible by 2. All odd numbers or a number that ends in 1, 3, 5, 7, or 9 are not divisible by 2. Let's practice. 76. The ones place or last digit of 76 is 6, which is an even number, so 76 is divisible by 2. 183. The ones place or last digit of 183 is 3, which is an odd number, so 183 is not divisible by 2. 2350. The ones place or last digit of 2350 is 0, which is an even number, so 2350 is divisible by 2. 6247. The ones place or last digit of 6247 is 7, which is an odd number, so 6247 is not divisible by 2. 8925. The ones place or last digit of 8,925 is 5, which is an odd number. So 8,925 is not divisible by 2. 15,148. The ones place or last digit of 15,148 is 8, which is an even number. So 15,148 is divisible by 2. Next is divisibility rule for 5, which states that if the digit in the ones place or the last digit of a number is 0 or 5, it is divisible by 5. Let's have an example. 50. The ones place or last digit of 50 is 0. So, 50 is divisible by 5. 375. The ones place or last digit of 375 is 5. So, 375 is divisible by 5. 8,600. The ones place or last digit of 8,600 is 0. So, 8,600 is divisible by 5. 9,415. The ones place or last digit of 9,415 is 5. So, 9,415 is divisible by 5. 3,000. The ones place or last digit of 3,000 is 0. So, 3,000 is divisible by 5. 21,105. The ones place or last digit of 21,105 is 5. So, 21,105 is divisible by 5. Let's practice. 35. The ones place or last digit of 35 is 5. So, 35 is divisible by 5. 190. The ones place or last digit of 190 is 0. So, 190 is divisible by 5. 2,572. The ones place or last digit of 2,572 is 2. So, 2,572 is not divisible by 5. 6,058. The ones place or last digit of 6,058 is 8. So, 6,058 is not divisible by 5. 8,000. The ones place or last digit of 8,000 is 0. So, 8,000 is divisible by 5. 42,093. The ones place or last digit of 42,093 is 3. So, 42,093 is not divisible by 5. 63,755. The ones place or last digit of 63,755 is 5. So, 63,755 is divisible by 5. Next is divisibility rule for 10, which states that if the digit in the ones place or the last digit of a number is 0, it is divisible by 10. Let's have an example. 60. The ones place or the last digit of 60 is 0, so 60 is divisible by 10. 700. The ones place or the last digit of 700 is 0, so 700 is divisible by 10. 5,000. The ones place or the last digit of 5,000 is 0, so 5,000 is divisible by 10. 90,000. The ones place or last digit of 90,000 is 0, so 90,000 is divisible by 10. 32,540. The ones place or the last digit of 32,540 is 0, so 32,540 is divisible by 10. Let's practice. 50. The ones place or last digit of 50 is 0, so 50 is divisible by 10. 830. The ones place or the last digit of 830 is 0, so 830 is divisible by 10. 3005. The ones place or last digit of 3005 is 5, so 3005 is not divisible by 10. 1972. The ones place or last digit of 1972 is 2, so 1972 is not divisible by 10. 10,000. The ones place or last digit of 10,000 is 0, so 10,000 is divisible by 10. Now, let's see what you already know. Let's have an activity. Find the divisibility of the numbers in the following table. Check the appropriate column. You can pause this video while writing down your answers. Okay, let's now check your answers with the key to correction. 65 is divisible by 5. 90 is divisible by 2, 5, and 10. 82 is divisible by 2. 275 is divisible by 5. 536 is divisible by 2. 850 is divisible by 2, 5, and 10. 1125 is divisible by 5. 444 is divisible by 2. 700 is divisible by 2, 5, and 10. 945 is divisible by 5. Now, let's proceed to the divisibility rules for 3, 6, and 9. Divisibility rule for 3, which states that if the sum of the digits of the number can be divided by 3 without remainder, it is divisible by 3. Let's have an example. 192. Let's add the digits of 192. 1 plus 9 plus 2 equals 12. So the sum of the digits is 12. Is 12 can be divided by 3 without remainder? Yes, so we can say that 192 is divisible by 3. 1476. Let's add the digits of 1476. 1 plus 4 plus 7 plus 6 equals 18. So the sum of the digits is 18. Is 18 can be divided by 3 without remainder? Yes, so we can say that 1476 is divisible by 3. Let's practice. 85,437. Let's add the digits of 85,437. 8 plus 5 plus 4 plus 3 plus 7 equals 27. So the sum of the digits is 27. Is 27 can be divided by 3 without remainder? Yes, so we can say that 85,437 is divisible by 3. 11,842. Let's add the digits of 11,842. 1 plus 1 plus 8 plus 4 plus 2 equals 16. So the sum of the digits is 16. Is 16 can be divided by 3 without remainder? No, there is a remainder. So we can say that 11,842 is not divisible by 3. $12,831. Let's add the digits of 12,831. 1 plus 2 plus 8 plus 3 plus 1 equals 15. So the sum of the digits is 15. Is 15 can be divided by 3 without remainder? Yes, so we can say that 12,831 is divisible by 3. 7,024. Let's add the digits of 7,024. 7 plus 0 plus 2 plus 4 equals 13. So the sum of the digits is 13. Is 13 can be divided by 3 without remainder? No, there is a remainder. So we can say that 7,024 is not divisible by 3. Next is divisibility rule for 6, which states that if the number is divisible by both 2 and 3, it is divisible by 6. Let's have an example. We will test if the given number is both divisible by 2 and 3. 126. The ones place or last digit of 126 is 6, which is an even number. So 126 is divisible by 2. Next, let's add the digits of 126. 1 plus 2 plus 6 equals 9. So the sum of the digits is 9. Is 9 can be divided by 3 without remainder? Yes, so 126 is divisible by 3. Since 126 is both divisible by 2 and 3, we can say that 126 is divisible by 6. We will test if the given number is both divisible by 2 and 3. 1308. The ones place or last digit of 1308 is 8, which is an even number. So 1308 is divisible by 2. Next, let's add the digits of 1308. 1 plus 3 plus 0 plus 8 equals 12. So the sum of the digits is 12. Is 12 can be divided by 3 without remainder? Yes. So 1308 is divisible by 3. Since 1308 is both divisible by 2 and 3, we can say that 1308 is divisible by 6. Let's practice. We will test if the given number is both divisible by 2 and 3. 536. The ones place or last digit of 536 is 6, which is an even number. So 536 is divisible by 2. Next, let's add the digits of 536. 5 plus 3 plus 6 equals 14. So the sum of the digits is 14. Is 14 can be divided by 3 without remainder? No, there is a remainder. So 536 is not divisible by 3. Since 536 is not both divisible by 2 and 3, we can say that 536 is not divisible by 6. (681). The ones place or last digit of 681 is 1, which is an odd number. So, 681 is not divisible by 2. Next, let's add the digits of 681. 6 plus 8 plus 1 equals 15. So, the sum of the digits is 15. Is 15 can be divided by 3 without remainder? Yes. So, 681 is divisible by 3. Since 681 is not both divisible by 2 and 3, we can say that 681 is not divisible by 6. (9,936). The ones place or last digit of 9,936 is 6, which is an even number. So 9,936 is divisible by 2. Next, let's add the digits of 9,936. 9 plus 9 plus 3 plus 6 equals 27. So the sum of the digits is 27. Is 27 can be divided by 3 without remainder? Yes. So 9,936 is divisible by 3. Since 9,936 is both divisible by 2 and 3, we can say that 9,936 is divisible by 6. Next is divisibility rule for 9, which states that just like divisibility rule by 3, if the sum of the digits can be divided by 9 without remainder, it is divisible by 9. Let's have an example. 216. Let's add the digits of 216. 2 plus 1 plus 6 equals 9. So the sum of the digits is 9. Is 9 can be divided by 9 without remainder? Yes. So 216 is divisible by 9. 1,476. Let's add the digits of 1,476. 1 plus 4 plus 7 plus 6 equals 18. So the sum of the digits is 18. Is 18 can be divided by 9 without remainder? Yes. So 1,476 is divisible by 9. Let's practice. 91,278. Let's add the digits of 91,278. 9 plus 1 plus 2 plus 7 plus 8 equals 27. So the sum of the digits is 27. Is 27 can be divided by 9 without remainder? Yes. So 91,278 is divisible by 9. 2,364. Let's add the digits of 2,364. 2 plus 3 plus 6 plus 4 equals 15. So the sum of the digits is 15. Is 15 can be divided by 9 without remainder? No, there is a remainder. So 2,364 is not divisible by 9. Now, let's see what you already know. Let's have an activity. Find the divisibility of the numbers in the following table. Check the appropriate column. Again, you can pause this video while writing down your answers. Okay, let's now check your answers with a key to correction. 1224 is divisible by 3, 6, and 9. 1926 is divisible by 3, 6, and 9. 4305 is divisible by 3. 2724 is divisible by 3 and 6. 3276 is divisible by 3, 6, and 9. 4881 is divisible by 3. 4284 is divisible by 3, 6, and 9. 99,207 is divisible by 3 and 9. 855 is divisible by 3 and 9. 483 is divisible by 3. Let's have an additional activity. Again, you can pause this video while writing down your answers. Which digit is divisible by the number? Write the correct digit or digits on the blank. Okay, let's now check your answers with a key to correction. 86 is divisible by 2. 140 is divisible by 2, 5, and 10. 2655 is divisible by 5. 1050 is divisible by 3 and 6. 3924 is divisible by 3, 6, and 9. 9099 is divisible by 3 and 9. Let's sum up. Divisibility rules for 2. If the number is an even number. 3 or 9. If the sum of the digits can be divided by 3 or 9 without remainder. 5. If the last digit is 0 or 5. 6. If the number is both divisible by 2 and 3. 10. If the number ends in 0. Kids, did you understand the lesson? If yes, that's great. If not, you can replay this video and watch again. If you also want to know the divisibility rules for 4, 7, 8, 11, and 12, please watch the part 2 of this lesson. Thank you for watching. Until next time.